On this episode of MythBusters, can a cardboard box become a lethal missile? Or is it a tissue of lies? And on the straight and narrow, the guys take aim at some archery folklore.
So close! So close!
Who are the MythBusters? Adam Savage
I reject your reality and substitute my own.
and Jamie Heineman.
We're either going to die or we're going to fly.
Between them, more than 30 years special effects experience.
That was intense.
They don't just tell the myths, they put them to the test. If this show has taught us anything, it's that when Mythbuster and automobile meet head-on, the result is usually carnage for the car. So, what's on the menu today? Let's see. One car, a bunch of crash barriers, a very nervous-looking Buster, and a tissue box? Oh boy, this doesn't look good.
Ow! Damn it.
This one is called the Killer Tissue Box, and
What are you doing up there anyway?
I got some new stills.
And,
Just doing a blueprint on stills.
okay.
Anyway, Killer Tissue Box says that this tissue box could potentially be deadly. That in an auto accident, if it's sitting on the back shelf of your car, when you collided with something, it would be propelled forward with enough force to actually kill you when it hit your head.
What, 60 miles an hour or so?
Something like that. Let's try.
I don't think this is going to kill you. What do you
No, I
think?
didn't really feel it. Try again. Okay, started to feel it right about there. Shall we do this full scale?
All right, why not?
Now, the simplest and most spectacular way to test this myth would be to place a tissue box on the rear shelf of a car, get Buster behind the wheel, and crash the vehicle at high speed. And you know what? That's exactly what the MythBusters are going to do.
One of the things that we have done in the past, because it's easier to do, is to simply drop cars to determine what kinds of impacts we get. In this case, gravity is an important thing because when the impact occurs, the object is sooner or later going to fall. You know, the question is whether it'll what speed do we have to achieve for the thing to go relatively straight from the back shelf right into the back of the head, and we can't test that in any other way than to actually get out there on a road and try this.
Here's our victimized vehicle. This poor old Fury's been left to the MythBusters' tender mercies before. In the drive shaft pole vault myth, Jamie rigged the Fury to operate by remote control. But this time, he doesn't want to sacrifice valuable and delicate equipment. So they settle on a more primitive form of remote control, otherwise known as towing. They'll still have to control the Fury's steering, so Adam sketches out a plan.
The wheel is attached to the car here and the steering comes down like this, right? We're going to attach a bar to the wheel that comes out here on each side. There'll be a pin here and a crossbar, and we're going to pull from this point forward. And this means that if this moves, this actually helps the car steer directly towards where it's being pulled. And to be honest, this point won't be forward of the front of the car, so it shouldn't affect the crash.
Building the steering rig will be Grant's responsibility.
So here's our Killer Tissue Box. I want to measure its distance to your head here. All right. It looks just about 42 inches. You know, I was thinking about tissue box flying in a car crash, and I was thinking anything that's moving forward is also going to be affected by gravity, so it's going to go down. Mm-hmm. But we got a lip on this back that the back seat creates, and that's pretty universal from my experience.
That's a nice little ski jump there.
Yeah, it's going to give it a little bit of something like that, so it might actually hit you right in the head there.
Okay.
Being a classic car, the Fury has bench seats and no headrests. There's nothing protecting the driver's cranium from the cardboard killer lurking in the back. But as this crash test footage graphically shows, modern vehicles offer precious little protection when backseat items go ballistic. And Buster's cousins were only doing 30 miles per hour.
It may seem like a freak occurrence, but in the United States in 2001, there were an estimated 13,000 people that were injured by unrestrained objects in the back of the car during an accident.
Well, we found 2 cases in Australia where drivers were impaled through their seat by their very own golf umbrellas.
And here in the United States, there was a young woman who was injured while leaving her local shopping center in a minor fender bender, and she was killed by the groceries she'd just purchased.
Food for thought.
Now, with Grant hard at work modifying the Fury's steering, Adam and Jamie have time to think. And that usually spells trouble.
What's the plan?
Well, obviously, we were prepared to crash a full-size car with a tissue box in it. But we don't just want to test a tissue box. We want to test a variety of objects. And we don't have enough cars to crash one for every object we want to test. So I think it's a perfect opportunity for us to build a repeatable crash test rig where we can see how each of these objects reacts under the worst-case scenario crash conditions without destroying our rig every time we use it.
The rig will have to be lightweight, yet able to handle huge G-forces. Even in low-speed collisions, people can be subjected to around 80 Gs. Astronauts pull only 8 at liftoff. Now, what materials should they use? Jamie's wandering around the metal supply shop like an art buff in a gallery.
6 or 7 inch square piece, that's pretty cool.
Steel will guarantee strength, but make the rig heavy to tow. Aluminum is much lighter, but then there's a chance the sled will disintegrate on its first run.
What I've decided to do, which is different, by the way, than Adam's choice, is to simply take a aluminum I-beam and attach it to the underside of a 4x8 sheet of aluminum, a diamond plate. And we'll do a little bit of reinforcement on it. Weight is actually fairly critical with this thing because the heavier it is, the harder it's going to be to stop. We'd have to go with a really heavy cable at some point. I'm trying to keep things really solid and robust and yet light. The only bad thing that can happen is all those rip, and I just don't see it happening.
Are you going to cut this off?
No.
Oh, okay.
The rig will be attached to the tow vehicle using a breakaway hitch made of wood. It should be strong enough to support the weight of the rig during acceleration, but weak enough to brake at the point of impact. Can't help thinking these guys must have built a mean go-kart. Adam adds a rear shelf for our tissue box to sit on. Now, they need a target. In the past, the MythBusters have used ballistics gel to mold recognizably human targets. But for this high-speed experiment, Adam's opting for a slab of gel in a box.
So this is one of the boxes that's actually going to hold my ballistics gel on the front of this car. You can see it's got a lip in here, and the lip is so that when I pour ballistics gel up to the top, it's actually captured by this mold. It's never going to get released from that. And hopefully, when this car stops at 50 miles an hour, the ballistics gel is not going to tear itself out of the mold.
Right, the crash test vehicle is ready.
That's good.
It's time to take this show on the road. Adam and Jamie have found the perfect place to test the killer tissue box myth.
We're in Alameda, California on an unused naval airstrip. And we need this because we need a long, straight, open run.
They've got 1,000 feet of cable. One end is attached to the crash test vehicle. The other is attached to 3 concrete barriers, each weighing 4,000 pounds. The barriers will act as an anchor. When that cable is pulled straight, their combined weight will bring the crash sled to a very sudden stop.
Slow down.
For serious grunt up front, they've hired a pickup, which will tow the sled up the runway at highway speed.
The first thing that I need to do is test how fast I can get this car going at about 1,000 feet, because that is the length of cable that we've purchased for testing this myth. Oh, cool. That's 75 miles an hour at about 1,000 feet.
Adam makes some final adjustments to the crash test rig.
Well, we've got our back seat here, and we've got our ballistics gel making a head here. The tissue box is going to go on the back shelf, and on impact, it's going to travel forward and hopefully hit our ballistics gel. With our meter here, which has got 1-inch markings, we should be able to see exactly what its velocity is and calculate how much force it's imparting to someone's head.
Time for a test run.
This is when we find out if all our hard work is for naught.
The truck hits 60 miles per hour. When the sled reaches the end of its tether, it should stop dead. The cable snaps, and the crash sled is like a dog let off its leash.
Damn it! Can we get a break, please?
How about we try that again? It's obvious we need a stronger connection. So this time, Jamie loops the cable through a hole in the I-beam.
Oh, I hope this works.
Take 2.
I hope this works.
We've got 200 pounds of metal on the move at 60 miles per hour. Crash cart and cable part company again.
I don't know what we're gonna do.
This time, though, the cable ripped an 18-inch tear in the aluminum I-beam. It's also taken a sizable chunk out of Jamie's ego.
No, that's my mistake. It makes sense now, seeing what it does. You know, I should have done the math. I should have done the engineering on it. I didn't do the engineering and I didn't do the math because I thought I understood what was going on and I thought I made a good rig, but I was wrong. I should have done it.
The cart is as light and as sturdy as it could possibly be, I think. But his method for holding the cable to the rig just did not hold up. I mean, it's really kind of shocking to both of us what the cable did to 18 inches of 1/4-inch aluminum.
That means the tissue box experiment will have to be postponed. Tomorrow's another day. Unfortunately, it also happens to be Saturday, and that's got one Mythbuster miffed.
I'm not happy at all about coming back on Saturday. You know, this is the last experiment we're doing this week. We're supposed to be done by now. It's sunset, and you know, we're all pretty tired. So nobody likes coming on Saturday, but we got to get this thing finished.
Cry me a river, Adam.
Thank you.
While Adam and Jamie go back to the drawing board, Tori and Carrie have gone back in time.
Carrie, I'm starting to feel like Robin Hood's merry men. Why are we dressed like this?
Well, we've come to the Renaissance Fair because we need to investigate a very classic Hollywood myth. Robin Hooding an arrow.
So this myth, we're talking about actually taking one arrow and splitting it with another one.
Why, our definition is going to be very Hollywood. We want to go from the tail to the tip.
Well, guys, you've come to the right place. At the Tulare County Renaissance Fair, there's no shortage of would-be Robin Hoods, all ready and raring to loose an arrow or two. And it's a fair bet that our anachronistic archers are familiar with this little piece of movie history. It's the 1938 classic, The Adventures of Robin Hood, starring Errol Flynn. Finding himself up against it in an archery contest, Flynn lets fly, producing the shot of a lifetime. Now that's what I call shafting your opponent. But is it possible? Or have we been Robin Hoodwinked? Our very own Little John and Maid Marian issue a decree.
Hear ye, hear ye! All ye archers in the land, this is the MythBuster Challenge. Is there any archer so skilled as to split a wooden arrow completely in twain, from nock to tip? Any archer capable of completing this task shall be awarded a kiss from the fair Sorry. Okay, yeah, you're not gonna get that. My mistake. What you will get is the coveted MythBusters Golden Arrow, our highest archery honor.
God save the archers!
God save the archers!
God save MythBusters!
God save MythBusters!
16 archers accept the challenge. We'll come back later to see how they get on. But of course, it's not the MythBuster way to just stand back and let someone else take pot shots at the myth. The build team's up to its own arrow-splitting antics. At Pacifica Archery in Daly City, California, the guys pick up a few basics.
So what is the definition of a longbow?
One piece of wood, okay, where the string doesn't touch the limb when it's strung. See here? How it's just on each point, it's not touching.
Not only have these guys heard the myth, they have a whole bunch of composite arrows which have been rear-ended Robin Hood style. Archers call it telescoping, and it's about a 1 in 3,000 shot. Modern arrows like these are designed not to split, so the guys will have to use a good old-fashioned wooden shaft for their test. At least now they know it's possible to fire one arrow into another.
Hey, you guys, look at this. I split the feathers. I didn't split the arrow, but I split the feathers.
Wow, look at that. That's getting really close. You think with some practice you could do this?
I think maybe we might be able to.
This chronograph is designed to measure arrow speed.
Fire one arrow.
It has 2 light sensors, one at each end. The chronograph measures the time it takes for the arrow to pass between them. Once it knows that, it can then calculate speed.
243 feet per second.
If Robin Hood ever did split an arrow, he did it using a bow like this.
We know from the excavation of a ship called the Mary Rose that longbows were the weapon of choice in Robin Hood's day, and they were usually made from a wood called yew, that's spelled Y-E-W.
Well, and the bows excavated from that site tell us that they averaged between 90 and 180 pounds of pull strength on those bows, although the larger ones were mostly used under siege conditions for armor piercing.
Well, modern bows rarely go above 60 pounds of pull strength.
But using a longbow takes a great deal of skill. If the guys hope to have any chance of splitting an arrow, they might have to employ a little modern technology. Compound bows are made from aluminum and fiberglass. Once the bow has been cocked, a pulley system kicks in, which takes the weight of the draw and makes it easier to aim.
Our chances of splitting an arrow are going to be much higher with a compound bow. It's got higher accuracy because you don't have to be fighting it in order to aim. Once the cams kick in, he can easily aim it. Plus, it's got much higher speed. So all of that kinetic energy is going to be going towards splitting the arrow.
While the build team have been delving into the world of archery, Adam and Jamie have been boning up on their folklore. Turns out the split arrow myth wasn't a Hollywood invention.
Adam, did you know that there is no direct evidence that Robin Hood ever existed?
Well, the first reference to him is a late medieval poem titled A Guest of Robin Hood, but there is no mention of arrow splitting in that poem.
The first mention of arrow splitting, I believe, was in a work called Ivanhoe, written by Sir Walter Scott in 1818.
And that's the Victorian era, and the Victorians were notorious for their hunger for anything that smacked of a fairy tale, and it's probably that era where this story built itself into such mythical proportions.
The build team's trying to split an arrow. Tori's going to be our archer. Thankfully, he's opted out of the traditional green tights. And our resident Robin in the Hood isn't feeling very optimistic.
This is the arrow that I'm supposed to split. Am I going to do that? I doubt it.
Going on what we saw the last time these guys picked up a bow and arrow, he might be right. At the end of the ancient death ray experiment, they were using flaming arrows to try and set alight their homemade Roman trireme. But the only thing to go up in smoke was their reputations. At least this time, Tori will be using his own bow.
So you actually go hunting with that bow?
No, I've never actually hunted with this. It was just for target practice, but my dad got it for me for Christmas.
The first arrow strikes the target, and straight away, there's a problem.
I'm wondering if that's going in too deep.
Carrie used hay as backing. Question is the hay letting in too much arrow?
See how deep it's going into the hay? And I think our chances of splitting the arrow are better if there's more arrow exposed.
So the hay's out, replaced by foam. Take 2 on the target arrow.
I think this is good because it's sticking out far enough and it looks pretty perpendicular to the target.
And you hit it in the same hole twice. That's pretty amazing.
Well, that's a good sign, right?
That's a great sign. Also, on the high speed, the block only moved a minimal amount.
Good.
Not nearly as much as the hay target.
So this is much better than the hay target.
Oh, yeah.
Perfect.
Okay.
Let's get to splitting.
Using modern aluminum arrows, Tori starts trying to split this myth right down the middle.
Okay, we're almost there.
Yeah, right.
No luck. Maybe if he moves closer.
I need all the help I can get at this point.
Let's try 15 feet.
You got really tight grouping, but it's above the target arrow.
Yep, really?
Yep.
He's getting close.
Are you ready?
Just kissing it.
Real close.
I didn't split it. I definitely hit it. Look at that, dude.
Oh, nice.
I chipped off the...
A glancing blow.
More arrows, more close calls, but no Robin Hood. Time for a change of tactics.
My feeling is if we switch to the broadhead arrow tips, our likelihood of splitting an arrow is much greater. Because right now, these arrowheads are just, I don't think, they're not a good design for splitting an arrow.
Oh, seriously, look at that. It's like throwing pencils at it.
Yeah.
This time, they're also going to shorten the odds of a split by giving Tori a whole Sherwood forest to fire at.
Oh, I got a split.
Did you?
Yeah.
Let's see.
I mean, it didn't split it right down the middle, but it definitely...
Oh, yeah, look at that. Look at that.
Split it about like 6 inches down.
That won't do, I'm afraid. We want to see an arrow cleft in twain, my friends. The problem seems to be the human factor.
Can't hit one of them. We're gonna have to figure out some kind of mechanical system to get an accurate shot every time.
Can't you make a robot?
I think so.
Let's make a robot.
All right.
A robot. Why not? In no time, Grant's whipping up an arrow shooting rig, designed to make the exact same shot every time.
So the bow goes here, string gets pulled, clipped into this thing, winch motor here, winch line here, pulls it back, and then this is the quick release, and that will release the string. Perfect shot every time.
For this to work, the bow will have to remain rock steady for every shot. So the bracket holding it in place has to be perfect.
Like a glove.
It's time to unveil the ArrowBot.
Here we go. 3, 2, 1.
Dude, that rocks.
Nice.
That rocks, dude.
Nice.
Now, let's see if the ArrowBot can hit the same spot.
Oh, that's sweet.
Looks like we could be onto something.
Oh, dude. That's amazing.
It's really close.
Yeah.
Nice work, brother. This is probably going to show us if it is in fact possible to split an arrow, because we're having it so it's dialed in, and then hopefully it will be shooting exactly in the same spot every single time. With a human, I don't think that's possible.
The first shot will be taken from 20 feet. The wooden target arrows put in place. The pointed tips are off, broadheads are on. Right, we're all set.
Oh, it's so close! So close!
Nice grouping, Grant.
Thanks, dude.
Even so, the trajectory of each arrow still varies slightly. So they're going to try the old bundle of arrows trick again. This time, the target shafts are so close together, there's barely any space between them.
I think we're going to split an arrow from nock to tip. I think we've got the optimal setup right here. The shooter is positioned. We've got a bundle of arrow shafts. I think the odds are very high that we'll be able to split an arrow.
That was before Grant saw this high-speed camera footage. It's a matter of aerodynamics. Arrows don't fly straight. They flex and twist in the air. So the question is, could one ever strike straight enough to carve another shaft straight down the middle?
3, 2, 1. 3, 2, 1. 3, 2, 1. That's way off.
But hang on, guys. Those aren't real arrow shafts, are they?
We got this doweling from the hardware store, but what we've discovered is that we actually should use arrow shafts, true arrow shafts that have the correct humidity, that have the correct grain, and hopefully with these new cedar arrow shafts, we'll have better results at trying to split.
The cedar shafts are screwed in place. Let's try it again.
3, 2, 1.
Somehow, the arrow found a way between the shafts.
That was a beautiful shot, but don't have a split arrow.
3, 2, 1. Ooh!
How's it going?
Another test, and this time, a partial split.
That is the best so
Down
far,
here.
right here.
Now,
This fell off this bottom one.
See?
3, 2, 1.
That was a good shot.
Grant's rig is right on target, but still no Robin Hood. Just a growing pile of kindling.
3, 2, 1.
There's another big piece. We got a little bit of a split here. I'm gonna go ahead and peel this off. But, you know, still not a Robin Hood.
Tori thinks the amount of kinetic energy being delivered to the target might be too great.
I don't know, I'm just thinking that this might be too powerful and it's just splintering them instead of actually splitting them.
The solution? Move the rig back. But now the wind is becoming a factor, and they're not hitting anything.
Well, gosh darn it.
This myth is fast becoming one ye old pain in the arrow shaft. Makes you wonder how they did it in the movie, doesn't it? Well, they did have this guy on set. Howard Hill was an uncannily accurate archer, arguably the best of all time. This modern-day Robin Hood won 196 field tournaments in a row.
And the distance is 30 feet.
Hill did a lot of work in Hollywood, and his own movies show just how good he was. Every shot was its own special effect.
And as though to prove his skill, he cuts a string at 12 paces.
If anyone was capable of splitting an arrow, it was Howard.
When he's run out of ways to shoot with his hands, he holds the bow with his feet.
But there's no evidence that he took the movie shot. One thing's for sure, Carrie and her cohorts could really do with Howard's help right about now. Adam and Jamie are trying to solve the case of the killer tissue box. Their new crash test vehicle came unstuck, prompting a rethink.
Adam, I've been running the numbers, and that 200-pound cart going 70 miles an hour has an enormous amount of force. It, I believe, comes out to about 35,000 foot-pounds of kinetic energy that it's applying.
Well, I mean, the problem we have is we can't make our sled any lighter. I mean, it weighs a couple hundred pounds. There's no place to actually remove any weight. I think the only option open to us is to slow down our testing speed and do all of these tests at like 45 miles per hour.
Okay, and I had another thought, and that was that we can use some heavy nylon strapping or something like that and wrap it around that whole I-beam, and maybe that'll distribute the load a little bit more.
I think that's great, and I think between those two things, we should actually get some good tests out of this rig.
Back at Alameda, the crash rig gets a makeover.
Jamie?
Yeah?
I think this is a really good solution.
These straps have a combined braking force of 40,000 pounds.
We are good to go on this end. Give us a countdown on your call.
Okay.
Right, let's give it another go. As another precaution, Jamie's going to lower the towing speed to 45 miles per hour.
Come on, come on, come on. Right there, I want it to stop right there. Yeah! That's what I'm talking about!
Perfect. The crash rig stopped right on cue. The cable stayed attached. To give you some idea of the force involved, the 4,000-pound concrete barrier was dragged along like a piece of styrofoam.
Jamie, that was perfect.
Exactly 45 miles an hour, over.
MythBusters now has a mostly working crash test sled. I'm very pleased, yeah.
Finally, we're ready to do some crash testing. Here are some objects you might find on the rear shelf of someone's car.
Well, this one's definitely the heaviest.
Right.
And so there's an argument to be said there that it could crush your head. This one also is fairly heavy. I'd say it's a toss-up between these two, and then this one's also, maybe this one could break your neck even if it doesn't crush your skull. That thing's about right up there with the Kleenex box.
Well, if the myth is correct, this Kleenex box is at the top of our lethality pyramid.
This little guy weighs just 125 grams. But remember, in a sudden impact, small objects can pack a big wallop, up to 30 times their own weight. Unfortunately, on this run, the bobblehead's not going anywhere.
The bobblehead fell over into the fence of screws and did not move, over.
At a certain speed, I'm sure that a bobblehead could be lethal, but I don't think that speed is 45 miles an hour.
Maybe we'll have more luck with the subwoofer.
Jumps.
The crash rig slams to a halt. The subwoofer keeps on going, striking the ballistics gel at 45 miles per hour. Put it this way, you'd really be able to feel the beat.
Just like we thought it might, the knob that describes the seat over the back shelf, that like 1-inch little riser, kicked this up, and you can see it go up, but it pretty much would hit you dead on in the head. We'll have to crunch the numbers to find out how hard, but it was a pretty good hit.
What if a hatchet hit ya?
You want to catch this? Check this out.
At 45 miles per hour, it'd be like something out of a B-grade slasher film.
Oh my God! Dude!
Look, the axe head's out on the other side of the board.
Not in a million years could we have done it that good.
Well, I think it's safe to say that you don't want to be carrying hatchets on your rear shelf.
This is your head. This is your head with an axe in it. Are we clear?
Well, we still have the fire extinguisher and the bowling ball to try.
A fresh gel cartridge is screwed in place.
That looked like a perfect hit.
The 1 kilogram fire extinguisher probably wouldn't be fatal, but it would definitely ruin your day.
It definitely didn't cut too deep. That's probably a really nice cushion for it. So I'm pretty sure that that could have given you a concussion or something like that if you got hit by it. But
but we can't really prove it by the ballistics gel. We'll have to look at the high-speed footage. Oh, there you go.
Yeah.
There's your proof.
There's your proof. Took a real hit there.
Yeah, if I whacked you on the back of the head hard enough to do that, you'd be hurting.
Now, the bowling ball. Actually, it's more like a cannonball. And remember, Jamie was only doing 45 miles per hour.
I think our rig has held up admirably. I'm not sure if it will hold up to 70 miles an hour, but it's time to see what a tissue box does at the worst possible speed.
All right, let's do it.
They put the rig back together. The tissue box is put in place.
Okay, this is the 70-mile-an-hour test. This is maximum speed, over. Okay, and going in 5, 4, 3, 2, 1.
Find out if this is actually deadly.
Jamie ups the pace to almost 70 miles per hour. The box of tissues imparts almost 50 foot-pounds. But at 323 grams, it just doesn't have enough mass to do much damage.
There's just no way. I mean, we tested a whole bunch of stuff. The bowling ball went right through this whole rig. Tissue box.
It might be like, ow, but I'm guessing that the ow from the airbag is going to be a lot worse.
Jamie, I think killer tissue box is definitively busted. Even if you had a decorative plastic or metal cover on this thing, it just doesn't have the mass to inflict lethal damage.
But we should point out to our viewers that anything that is sharp or weighs over a couple of pounds or so is not something you want to have unrestrained in the back of the car, even in the back seat, because it could be, if not lethal, definitely dangerous.
Absolutely, but I think the final word on this should be left to Buster, who is living proof, such as it is, that in a head-on 70-mile-an-hour collision, this is the very least of your worries.
Our trio's still trying to split an arrow. They've moved Grant's rig back indoors.
We had to move the rig inside because it turns out the wind is really becoming a factor with these arrows, and our accuracy is totally off. So we've moved everything inside, and we're going to try this experiment again.
Our current thinking is that there's too much kinetic energy. One of two possibilities is our fired arrow comes in and hits a target arrow and just shatters it. The other possibility, and this is Tori's theory, is that the fired arrow comes in and hits a target arrow which flexes, and it doesn't allow us to get a clean shot down the middle. So hopefully, by reducing the amount of velocity, we can reduce the kinetic energy and get a clean split right down the middle.
Still nothing.
We've given up. Obviously, from any distance, we're not getting the accuracy that we need in order to split the arrow. We're going to take accuracy out of the equation and move into the end of an arrow. We're going to put the machine right on it, fire it, and see if that is able to split an arrow.
They set up for a point-blank shot. Will the target split, or might Tori be on the lookout for a new bow?
There's a minor possibility we might break Tori's bow, but the producer has agreed to buy Tori a new bow.
3,
Everyone
2,
takes cover.
1.
Oh, that happened. All right, well.
Dude, this is...
It split it around 6 inches.
Looks like there could be a split in the build team as well.
Guys, in my mind, this is busted. I mean, there's no way anybody's going to be able to do this on command if we're right up against it with every possible accuracy established. I'm thinking this is busted right here, personally.
Now they're splitting hairs.
Well, the only problem is that how we defined it is it possible? We didn't add the on-demand part.
Yeah, but that is the myth. I mean, he has to be able to do it one right after the other. Otherwise, it's just a fluke.
It's possible.
It is a fluke.
On a fluke, but that's not the myth. On a fluke, that's just silly.
I think it's too soon to call it busted. I think it is possible. Maybe it's not, but I just think it's too soon to call it busted.
I'm willing to give it another shot, but you guys are gonna have to prove to me that this is possible on demand for me to actually personally feel it's confirmed or plausible whatsoever.
Back in the days of yore, at the Tulare County Renaissance Fair, 16 noble archers have accepted the MythBusters challenge. Whomsoever can split a wooden arrow from nock to tip shall claim the coveted golden arrow. Each contestant gets 3 shots. When that doesn't work, they all fire in formation.
Ready! Draw! Aim!
I don't know. I didn't see any splitting arrows.
The target's got more bristles than a porcupine, but there's still not a split arrow in sight.
How many of you have done it before?
Hi.
I've done some archery, you mean? Yeah.
No, I split the arrow.
Not splitting all the way down.
Not all the way down
to the head.
Half. Only got halfway.
Travis Fletcher is master of an archery guild whose members shoot at Renaissance fairs all over the state. He has his own ideas about the origin of the myth.
The splitting of the arrow was actually more likely an archery game that was used in order to train the archers. It was called slisting the wand, where the an arrow would have been set as a vertical target, either in the ground or against a tree, and then the archers would have attempted to split the arrow or slist the arrow with theirs.
We came here to see if any archer could split an arrow, and it doesn't look like it's gonna happen.
Yeah, you know what? I'm starting to think that this is impossible.
Looks like we're gonna have to take the golden arrow home with us.
Oh, that's too bad. And we are locked and loaded.
Back at MythBuster HQ, they're still trying to split an arrow. It took less time to split the atom.
And 3, 2.
Once again, they've got arrow and target shaft touching.
Look at the angle. It just kind of carved it out.
Tori and Grant study the high-speed shot.
The blade of the arrow is just basically following the grain of the wood and just popping out where it ends.
Yeah, also I see that the arrow is kind of flexing on impact.
Yeah, maybe what we should do is make a channel so that way the shooting arrow follows that all the way down the target arrow and it has no chance of moving.
Right, they're like totally aligned, and then as it goes through, we get a straight split.
Yeah.
Okay.
Some might call it thorough. Some might call it cheating. Grant fashions a thin tube that encases both arrow and target, holding them in exact alignment. Hopefully, the arrow will be guided all the way along the target shaft, splitting it right down the middle.
3, 2, 1.
They try a copper tube.
3, 2, 1.
They try carbon fiber, but nothing can stop that arrow from following the grain.
So as far as I'm concerned, with all of our testing, which I believe was extremely thorough, I'm calling this one busted. You cannot split an arrow from the tail to the tip, and unless somebody can come out of the woodworks with either a video or does it right in front of my eyes on command, one after the other, I'm saying this is busted.
I'm totally with you. Busted.
Busted with a capital B.
Adam and Jamie have busted the killer tissue box myth. But if you think that's going to stop them destroying the Fury, you're sadly mistaken.
Jamie, can you help me?
That car's going to be towed along the tarmac at top speed straight into these crash barriers.
It's kind of important that they be lined up just so because each one of these only weighs about as much as the car does, and the car is going to be traveling quite quickly. So with that in mind, we've overlapped them and put one in the back of them so that they'll hopefully not move too far with the impact.
Before they get too carried away, they'll have to make sure Grant's steering rig works. That means a test tow.
Worst case scenario is that we start up with the truck dragging the Fury, and the Fury goes way off and like smacks into something of value. like a crew member.
To make sure that doesn't happen, Adams volunteered to get behind the wheel of the Fury.
Last time I was in this car, Jamie lost control of it with his RC controller and sent me through a fence. Cut to shot of Adam going through fence. Jamie!
Whoop.
This is working beautifully.
Jamie guns the pickup.
I'm in a car and I'm not touching anything.
What'd it do? Were you still having to steer it at all?
I didn't have to touch it.
Oh man, that's great.
Yeah, it was absolutely beautiful.
Well, that's what I wanted to hear.
It veered off by about a half a degree when you were moving, and then you started moving forward and it corrected. So, I mean, it's exactly what we wanted it to do. Let's crash this puppy.
All right.
They just have to replace Adam with another dummy. For once, Buster, you should feel right at home.
And now, the final and perhaps deadliest component of this test. The tissues.
Okay.
This is actually really scary. You know, we did a test. It seems like it's working okay, but 4,000 pounds of car rolling kind of on its own at 50, 60, 70 miles an hour is a scary thing, and we've got to kind of thread a needle with the end of it. So this is just, I'm going to be way the heck down there. That's all I know.
One end of the cable is attached to the Fury. The line's then threaded through holes in the barriers, and the other end tied to the pickup. Jamie floors the accelerator.
The car looks great.
The Fury chews up tarmac and hits the barrier at more than 60 miles per hour. Cue manic laughter. At the point of impact, the front of the Fury leapt up in the air, so the tissue box's trajectory took it into the back of the seat, instead of Buster's noggin.
So, Grant, what's the time to reset and do this one again?
Yeah, it's gonna take a little bit more than 20 minutes, I think.
Oh, let's see. Okay, what was your speed at impact?
65 miles an hour.
Amazingly, the box survived intact. The cardboard's not crumpled. There's not even a single torn tissue.
Let's see, is there a Buster-shaped head imprint on this? No,
Well,
looks pretty good.
You know, that's a good indication that this is really deadly, though. That's the one thing in the car that's tough enough to survive an impact.
Grant plugs into the accelerometer implanted in Buster's head.
114.8 Gs.
114.8?
Yeah.
Dude, that's very significant.
Very significant. Remember, an astronaut pulls only 8 Gs during liftoff.
This came out of the accelerometer, and what I've got right here is interesting. At 100 milliseconds, remember I said it's a peak of 115? That's the modulus of all three axes. And here, in the Z direction, I have about 75, and in the X direction, I have about 90. So Z being top of the head, and X being side to side. So I think he must have turned
and smacked his head on the dash.
I think so.
So you think maybe is that Buster was trying to twist out of the way of the deadly tissue box as it was making its way like a bullet towards the windshield?
Well, if that's the case, then clearly the second spike has to be the tissue box hitting Buster in the head.